Hello! In this video, we are going to prove the following theorem. Every subset of real numbers that has a supremum has exactly one supremum. Okay, now before we get into the proof, what is a supremum? Well, here's the definition we're going to rely on. Given any subset of real numbers S and a real number U, we say that U is a supremum of S if it satisfies the following two conditions. The first is that U is an upper bound of S, and the second is that for every upper bound U prime of S, U is less than or equal to U prime. So in other words, this tells us that U is the least upper bound of S. And so that's the idea of a supremum. Now, we want to prove the theorem. And we're trying to prove a statement about every subset of real numbers, so give me an arbitrary subset of real numbers. I'll call it S. And from here, we want to prove if S has a supremum, then S has exactly one supremum. So let's suppose that S has a supremum. Our goal now is to show that S has exactly one supremum. So essentially, we have the existence portion. All we need now is the uniqueness portion. And to prove uniqueness, we're going to suppose S has two supremums, U1 and U2. And the whole goal to prove uniqueness is to show that U1 is equal to U2. Now to start, by definition of a supremum, we know that U1 and U2 are both upper bounds of S. However, another thing that comes from the definition of a supremum is that U1 and U2 are both least upper bounds of S. More precisely, if we take the U in our definition and replace it with U1, well, by fact number 2, we have that for all upper bounds U prime of S, U1 is less than or equal to U prime. Well, since U2 is an upper bound of S, we can take the U prime here and replace it with U2. And we get that U1 is less than or equal to U2. In a similar way, we can take the U in our definition and replace it with U2. And by part 2, we have that for all upper bounds U prime of S, U2 is less than or equal to U prime. Well, since U1 is an upper bound of S, we can take the U prime here and replace it with U1. And we get that U2 is less than or equal to U1. So, putting this together, U1 is less than or equal to U2, and U2 is less than or equal to U1, therefore U1 is equal to U2. And that proves uniqueness. So, we have shown that given a subset S of real numbers, which has a supremum, it has exactly one supremum. And that's exactly what we wanted to prove, so this completes the proof. And so yeah, that's pretty much it for this video.